Okay, Assalamualaikum. This is the next video after our introduction just now. So thank you for your attention again. Subchapter 4.2 Data Communication Interface and Networking. Okay, the TCP/IP protocol soups. The DoD and OSI models are alike in design and concept and have similar functions in similar layers. Okay, so this is the DoD model. Just now we have discussed application layer, host to host or transport layer, internet layer, and fourth is the network access layer. Okay, process or application layer. This section describes different application and services typically used in IP networks. The following protocols and applications are discussed. So we will discuss about the services in application layer. Okay, first is the telnet. Second is the FTP. FTP is file transfer protocol, and next is the TFTP, trivial file transfer protocol. Then NFS, network file system, and then you have SMTP, LPD, line printer daemon, X window, SNMP, DNS, DHCP, and so on and so forth. Host to host layer, or known as transport layer. Okay. The main purpose of the host to host layer is to shield the upper layer applications from the complexities of the network. This layer says to the upper layer, just give me your data stream with any instruction and I will begin the process of getting your information ready to send. Okay, the following sections describe the two protocols at this layer, at the host to host layer or transport layer. First is transmission control protocol, TCP, and then next is UDP, which is user datagram protocol. Okay, let's see what is contained in the header of TCP. TCP, Transmission Control Protocol. The figure shows the different field within the TCP header. Okay, so you can see here there are total is 32 bits from bit 0 to bit 31. And it has 24 bytes. Okay, this is 24 bytes. The content of the TCP header are, first is source port 16 bits, destination port 16 bits, sequence number, acknowledgement number, header length, reserve, code bits, window. Okay, and you have checksum and adjourn 16-bit ish, options if any, and the data. Okay, then you have the data. So these are the field within the TCP header. Next we have the content in the UDP, User Datagram Protocol. This figure clearly illustrates UDP markedly low overhead as compared to TCP hungry usage. So for UDP it is less complicated. It is more simple. So same for the number of bits, where you have 32 bits from bit 0 to bit 31. But the content only only have a source port and destination port, each at 16 bits. And then you have length and checksum for 16 and 16 bits. And then straight away you have the data. So UDP header is much more simple compared to TCP. Key concept of host-to-host protocol. So this is the comparison between TCP and UDP. TCP, sequence, reliable, connection-oriented, virtual circuit, acknowledgement, and windowing flow control. Whereas for UDP, you have unsequenced, unreliable, connectionless, low overhead, no acknowledgement, no windowing or flow control. So that is the comparison between key concept of TCP and UDP. Port numbers. Port numbers as an example for TCP and UDP. So you have application layer, port numbers, and transport layer. So for TCP, you have for FTP 21, Telnet 23, DOM 666. Okay, for UDP you have DNS 53, TFTP 69, POP3 110, and News 119. Key protocols and port numbers. So for TCP and UDP, you are having different port numbers. Okay, Telnet 23, 20, SMTP 25, HTTP 80, all these different application and different port numbers. Numbers greater than 1024 are used for upper layers to set up session with other hosts, and by TCP to use as source and destination address in the TCP segment. The internet layer. So here shows the header for internet layer, where you have this 32 bits, but the depth is 20 bytes. Okay, the layers. So for internet layer, you have version, header length, priority and type of service, and total length. Then identification, flags and fragment offset, time to live, protocol, and header checksum. Then you have source IP address, destination IP address, options, and data. Okay. So for internet layer, protocol field in IP header, you have protocol numbers 6 for TCP and 17 for UDP. So these are the protocol field in IP header. So you have the application and the protocol number. You have ICMP, IP, IGRP, Interior Gateway Routing Protocol, EIGRP, OSPF, IPv6, GRE Generic Routing Encapsulation. Okay, IGRP, OSPF, GRE. So these are the application and the protocol number. IP addressing. An IP address is a numeric identifier assigned to each machine on an IP network. So now we are discussing about IP address. So IP address, the definition is an IP address is a numeric identifier. It is a number assigned to each machine on IP network. It designates the specific location of the device on the network. It shows the location, the specific location of a device on a network. IP addressing was designed to allow hosts on one network to communicate with a host on a different network, regardless of the type of length the hosts are in, the hosts are participating in. So these are description about IP address. The internet layer. The Internet Control Messaging Protocol, ICMP, works at the network layer and is used by the IP for many different services. ICMP is a management protocol. For example, ICMP is a management protocol, a messaging service provider for IP. Its messages are carried as IP datagram. ICMP packets have the following characteristic. They can provide hosts with information about network problem, and they are encapsulated with IP datagram. That is about ICMP, Internet Control Message Protocol. Okay, next is the internet layer. The internet layer, the figure shows the connection between host A and host B. Okay, EO on leg B is down. Okay, this part. Host A is trying to communicate to host B. Host A is trying to communicate to host B. What happens? Okay, this is the internet layer. ARP, Address Resolution Protocol. ARP resolve IP address to Ethernet MAC address. Okay, so this is the IP 10.1.1.2. Okay, so you have a frame header, MAC header, IP header, and ARP request message. Internet layer ARP, Reverse Address Resolution Protocol. So this is a content of the RARP, MAC header, IP header, and RARP request message. Okay, that's all. So that's all for this part. We will continue another part in next video. So thank you very much for your attention. Hope you can understand some part of this topic. Until then, thank you very much. Bye bye.